Hello dear friends, welcome back to my YouTube channel Chemistry Aspirant. Now in today's lecture, we are going to learn about the formation of molecular orbital energy level diagram for carbon molecule. In the previous lecture, we already learned the formation of molecular orbital energy level diagram for boron molecule. The link of this video is given in the card. Kindly watch that video also. If you follow all my videos, from the few previous lecture we are discussing the same with the different molecules, and there we generally considered 7 to 8 simple points by which you can simply explain the formation of any molecule. So here we are also going to explain the 8 simple points by which we can simply explain the formation of carbon molecule. So let's start with the point number first. We know that carbon molecule is made up of 2 carbon atoms, and each carbon atom in the ground state has 6 electrons in the 1s, 2s and 2p atomic orbitals. Then we considered the electronic configuration of the carbon atom. We know that carbon atomic number 6 and its electronic configuration will be 1s2, 2s2 and 2p2. So that is our point number first. Now the point number second, that is the calculation of the total number of electrons in the carbon molecule. So here we know that generally carbon molecule made up of 2 carbon atoms, and each carbon atom contains the 6 electrons. Hence the carbon molecule will contain total 12 electrons, which we are going to distribute in the different molecular orbitals in the carbon molecule. So that is your point number second. Now the point number third, that is the construction of molecular orbital energy level diagram. The linear combination of 2 1s, 2 2s and the 2 2p atomic orbitals of both carbon atom forms the 10 molecular orbitals. Now out of that 10 molecular orbitals, the 5 are the bonding molecular orbitals. These are actually the sigma 1s, then sigma 2s, then pi 2px, pi 2py, then next that is sigma 2pz. So these are the bonding molecular orbitals, while the remaining 5 are the anti-bonding molecular orbital, and these are the sigma star 1s, then sigma star 2s, then pi star 2px, then pi star 2py and the sigma star 2pz. So these are the 5 anti-bonding molecular orbitals. So here these 12 electrons are distributed in these bonding and the anti-bonding molecular orbitals by following Abou's principle, Pauli's exclusion principle and Hund's rule. So here let us consider this distribution of the electrons. So the first 2 electrons will enter into the sigma 1s bonding molecular orbitals. Then the next 2 electron will enter into the sigma star 1s anti-bonding molecular orbitals. So total 4 electrons are used. Now the next 2 electrons will enter into the sigma 2s bonding molecular orbital, and the next 2 electrons will go into the sigma star 2s anti-bonding molecular orbitals. So 4 plus 4, 8 electron is used, only 4 electron is remain. So out of the remaining 4 electrons, the 2 electrons will enter into the pi 2px and pi 2py bonding molecular orbital, and this leads to the formation of molecular orbital energy level diagram for carbon molecule. So that is your point number third. Now the point number 4, that is the electronic configuration of this molecule. The electronic configuration for the carbon molecule I have written in this manner: sigma 1s2, then sigma star 1s2, then sigma 2s2, then sigma star 2s2 and pi 2px2 and pi 2py2. So this is the electronic configuration for your carbon molecule. So for writing this electronic configuration, I have taken the reference of the point number 3rd, where we have distributed the 12 electrons in this different molecular orbitals. So I have taken it in the sequential manner and I have written simply the electronic configuration for it. This is about the electronic configuration of carbon molecule. Now the next point that we considered is the bond order. The bond order can be calculated by using the formula 1/2 into Nb minus Na, where Nb is the total number of bonding electrons and Na is the total number of anti-bonding electrons. So for carbon molecule, here the Nb is having the value 8 while the Na is having the value 4. Therefore, by putting all these value in the formula, that is bond order equals to 1/2 into Nb minus Na. Therefore, 1/2 into 8 minus 4. Therefore, 1/2 into 4, and finally by simple mathematical calculations, that is bond order will be equals to +2. So here the two carbon atoms will link with each other by the double bond. Now the next point, that is the stability of molecule. We know that the stability of molecule depends upon the two important factors. That is, the first factor as a total number of electrons in the bonding molecular orbital and total number of electrons in the anti-bonding molecular orbital, and the second factor is the bond order value. So here you can observe that the number of bonding electron in the carbon molecule is greater than the number of electron in the anti-bonding molecular orbital. So here the value of a Nb is greater than the value of a Na, and bond order is having the higher positive value. Hence the molecule which containing the carbon-carbon double bond will be the stable molecule. Now next, point number 7, that is the number of bond, then the bond length and the bond dissociation energy. So here you can observe that the number of bond between the two carbon atom is 2, then the bond length is 1.09 angstrom. So the bond dissociation energy is 9.756 electron volt. Now the point number 8, that is the magnetic property. So here you can observe that the all electrons in the bonding molecular orbitals are the paired electron, and hence the carbon molecule is diamagnetic in nature. These are the 8 simple points by which you can easily explain the formation of carbon molecule by using molecular orbital theory concept. Hope you will like this video. Thank you so much for watching this video. See you in my next video.